This activity will be an assignment in both algebra and math lab. In algebra, it might be weighted differently. Like I know in my algebra, I'm doing it as a project. For math lab though, it's going to be an assessment and I'm giving you like double the time to do it because you would have worked on it today in algebra and now in math lab. If you don't have it yet, I'll give you one, don't you worry. But the skill that we are practicing is multiplying binomials specifically. That's the really important one. There are some other things on here like trinomials and such. Also, side note, do you guys know what it means for something to be a binomial?
Two-term expression.
Yes. So the prefix bi kind of clues you in two, bi means two, and binomials are two-term expressions. So for almost all of these, we have a two-term times a two-term. That's what we mean. That's the major skill that I need you guys to leave with today. We've kind of been practicing it in lesson 8 and 9. Now you have like just very direct practice on just those skills. But you also will see, like down here, a binomial times, what do we call it if it's 3 terms? A trinomial, good. That's more like a bonus, I guess. That's like a bonus learning thing. You still need to know it for like your future math and stuff. But the main skill that I need you to leave with today is how to multiply 2 binomials together. Multiplying a binomial times a trinomial, you can do the double distributing, where you take one term and multiply it by all the terms in the other parentheses, and then go back, take the other term, and do the same thing. Except now there's just more to do. You could make a diagram. It'll just look a little bit different in order to account for the trinomial now. But you can't do foiling when it's a binomial times a trinomial. Foiling only works when it's a binomial times a binomial, like these ones up here. So that's why we showed you all the methods. Really, you can pick whatever method you want. And I need you at a minimum to do where you just get the answer from multiplying. The coloring would be extra credit. And the coloring would require you to, once you have your answers, in this set, it wants you to add your answers together. In this set, it wants you to subtract them. That is optional. It's still a really good skill, but that's what you would do if you needed to color it. But adding the answers together, subtracting them, because then it'll tell you what color to color that number. So once you add them or subtract them, depending on the instructions, you'll get one of these answers. And that'll tell you that for number 7, you color it dark blue and things like that. So let me make sure everyone has one. What? Which one do you want to see worked out? Which one looks hard? Did I hear all of them? Okay, number 6 we'll do first, because that was the first class. So here's number 6, if you all want to follow along. You can use whatever method you want to multiply them together. What method do you like? Like foiling, double distributing, or the box diagram? Okay, we can do the box on this one. And we can do something else on the other one. If you are using the box method, or really any method, just make sure you pay attention to the sign that's in front of each term. It like stays with that number. So if I'm setting up my box method here, I would have a positive 4x, a negative 5, a positive x here, and a negative 2 here. The terms from the same parentheses would need to be on the same side of your box for it to work. And then inside your box, you can multiply them. So table 4, what's 4x times x? Good. Table 5, what's -5 times x? Okay, good. Table 6, what's 4x times -2?
-6. Okay.
Times them.
Oh,
Correct.
-8.
-8x, and then table 7, -2 times -5. A +10. Then when you go to write down your final answer, you are combining like terms. Table 1, does this 4x squared have a like term? So you just, so it's still in your answer, you just don't combine it with anything. Table 2, does the -5x have a like term? What's its like term? And we are adding those now. A common mistake I've been seeing is people have been multiplying those. When it comes to combining like terms, combine means add. So what's -5x minus 8x? -13x. So -5x plus -8x, you can say it that way too. And then that 10 is still there, that one doesn't have a like term. So that's me getting the answer, that's like the minimum requirement for the points on this. I need you to show work and have a final answer for each one. The coloring part is like the optional part. Okay, now the other part of number 6, let's try that using a different method. So foiling or double distributing, which one do you want to see? Okay, I heard double distribute. So that means you take one term from the first parentheses, multiply it by both terms in the second. What's x times x? What's x times -5? -5x. Then you take the other term, the one that you didn't mess with yet, this one, distribute it to the other terms in the other parentheses. Class with -5 times x. And -5 times -5. A +25, and I'm gonna show that with the plus sign. Because you don't wanna just write it up against the x, I've been seeing that too. You wanna like separate them, the different terms. Combine any like terms, usually it happens to be your x terms that you're combining, so like these ones. What's a -5x plus -5x? Good, it's negative, make sure you show that. And then bring down the other terms that were there that do not have like terms. Okay, so questions on that part? So that's your minimum requirement, it's getting to those answers. The part about what to color, that's like additional extra credit, I would just do all of this first. But if you're interested, maybe you do get that far ahead. For this set, it says to take the sum of your answers. That's easy because that means you just add them together, combine like terms. When it comes to difference, it's a little bit different, so you know, if you get to that, let me know. But that means you would add the like terms together. So like, what's 4x plus x squared? So I have 4x squared and I add another one, how many do I have? No, we're not multiplying them, we're gonna add them. So here, let me put some more scratch work down because I don't think people know what's going on. I'm adding these terms together. And note that outside of every parentheses, there's always a 1, even if it's not written. Distributing the 1 is what gets rid of the parentheses. These both happen to be a positive one, so that doesn't really change anything. I just want to show you that's why the parentheses can go away when you distribute that imaginary one that's on the outside. And we're adding these together. So combining like terms. What is 4x squared plus x squared? Can you tell me what 4x plus x would be? Now I'm changing the question because you guys aren't getting there, so make sure you're listening to the question I'm asking. What 4x plus x?
Oh, 4x.
4x plus x. If I have 4x's and I add one more, how many do I have? 5x. So then when I have 4x squared plus x squared, then be 5x squared. Combine like terms, they have to be like terms, so like these both have an x squared. But combine, you're really just adding the numbers in front. And then you leave the rest alone. Okay? I kind of cross them out as I go, so I already combined these. Does the negative 13x have a like term? Negative 10x, what's negative 13x plus a negative 10x? Combine means add the numbers in front. What's negative 13 plus negative 10? Okay. So negative 13x plus negative 10x is negative 23x. Does this 10 have a like term? What's 10 plus 25? And it's positive. This matches one of my colors. It matches, and I know it's cut off on some of your papers, it's copied all one piece. So I'll have a reference up here too, that it is in Schoology. Let's see. Gray. So for number 6, you'll color those gray on the back, which again is extra credit. So like a lot of you kind of struggled on that. Maybe don't make that your priority. Maybe get to what I boxed up here. That's your priority. That's the skill I need to go with today. The rest is just addition. I'm gonna leave this example up, but the document that has the rest of the colors and stuff is in Schoology. You just click on the assignment link, hit view, and then you can look at it on your phone. Questions? Right, then don't spend any longer than maybe 2 minutes, 3 minutes on a problem. This is gonna be an assignment for algebra and math lab. I wanna be able to like give you a score today, a good one before I give it back to you so that you can resubmit it. All right, so number 11, that was one of the binomials times a trinomial. You could do the diagram, you could do double distributing, you can't do FOIL. Okay, there's no first, outer, inner, last in this, you'd be missing some terms. So I'll show you with the diagram first. Because it's a trinomial times a binomial, oops, that's it. I have to make my diagram fit all of that. So what do. And remember, each parentheses needs to be like on the same side. So the smaller side would have to be my 2-term expression. Make sure you keep the sign that's in front of each term. On this longer side would have to be my 3-term expression. Notice I don't necessarily write the plus if it's positive, but later, like I'll need to when I put it all together. But you definitely need to write it if it's negative. And then in each square, you are multiplying. What is x times x squared? So remember your exponent rules, it's the same thing we did when we would do x times x. We were adding the exponents. So what's x times x squared? What's the exponent on this one, or not this one, on this x? What's 1 plus 2? So this will be x cubed. Boys, stop talking. That's this square. Then keep multiplying for each dimension of this box now is 8x by x with 8x times x. 8x squared. Because right now we're multiplying, right? That's different rules than if you were adding. So 8x squared is this one. What's x times -1? Now I'm on to this square. What's -2 times x squared? Good. In this box, what's -2 times 8x? And in this last one, -2 times -1. A +2. Okay, so that's me multiplying individually. The diagram helps me organize it. When I write my final answer, I'm gonna combine like terms kind of as I go. So does this x cubed have a like term? Is there any other x cubed in here? So then it doesn't, it's just gonna be x cubed in my answer. I'm gonna kind of cross out as I go too. Does this x squared have a like term? Yeah, I have another x squared term here, so that's what we mean by like terms, that's have the same variable with the same exponent. And combine means add, so really you're just adding -2 plus 8, what's that? A +6, and then x squared is still there, you don't change the variable part when you combine. I'm gonna cross these out because I'm done with them now. Does this x term have a like term? Yeah, I have another x term to the first power. What's -16x plus -1x? -17x. You could use a calculator for the numbers. -16 plus -1 is what we just did. The x part is still there. And then lastly, we have that +2. This is my answer for this part of 11. And, okay. Now in this one, I'll show you a different method. The only other method you could use is double distributing. Because now we have to distribute to 3 terms instead of 2 terms. So first I'm going to distribute the x. What's x times x squared? X cubed, good. What's x times -5x? So that would be maybe you adding them, so it would be a little incorrect, but x times -5x. The number in front of the x is 1. So it's -5x squared. What's x times 9? And that's positive, make sure you put the plus sign. And that's me distributing the x. I need to distribute again, that's why we call it double distributing, but this time I'm distributing the 4. What's 4 times x squared? And I think I'm running out of room, I'm gonna try to squeeze it. It's positive, so make sure you show that it's positive. What's 4 times -5x? -20x. What's 4 times 9? Good, and it's positive, sorry, I have to squeeze it in right there. But yeah, now when you write your final answer, you combine like terms, so Does the x cubed have a like term? So just write it. Does this negative 5x squared have a like term? Yes, here's another x squared, I can combine it. What's negative 5x squared plus 4x squared? Sorry, one more time. Okay, good, and it's a negative, don't forget to show that, negative 1x squared. I'm gonna cross them out now. Does this 9x have a like term?
Even if they're the same.
What's 9x plus negative 20x? Negative 11x. And then last but not least, that 36, there's nothing else to combine it with, no other single numbers, and that's this answer. Now, if you want to do the coloring part, on this set, it said to find the difference. That would be you taking this and subtracting this whole trinomial, or not trinomial, polynomial, because there's many terms. Remember that there's always a 1 outside the parentheses. I think I'll try to squeeze me doing that down here. Because you can't just put a minus sign in the middle and then start combining. You have to distribute the ones, make the parentheses go away. And when we are subtracting polynomials, that minus makes a big difference. So like distributing a positive 1 doesn't change anything, right? So like this first polynomial is gonna look the same after distributing that 1. But over here, I have a negative 1 outside this parenthesis. When I distribute a negative 1 to everything inside, it changes all of the signs. So then it becomes, we're minusing x cubed, adding x squared, adding 11x, and subtracting 36 from this other polynomial. Okay, so this changed all the signs. So when I go and now I combine like terms, I distributed that negative 1. What's x cubed minus x cubed? Zero, so that really cancels out. My work is a little unorganized, but hopefully you're following what I'm saying. What's 6x squared plus x squared? Seven x squared, and that's positive. I mean, I guess I don't need to write the plus this time, but I just combined these. What's negative 17x plus 11x? Negative 17x plus 11x. Negative 6x. And now 2 plus negative 37. All right, so for that one, we are coloring it purple. 11 will be colored purple based off of that. Now, again, that whole third part we did is so optional. All you really need to be able to do is what I'm starring right here. But that whole coloring part, that's how you do it. Because now you take those answers, either add or subtract them based off the instructions, and then it'll match one of these answers down here. Okay, good questions about that? Okay. I will come around with my clipboard and just kind of mark how much you did. But I'll probably wait till like 9:15 to do that.